Alright guys, welcome back to another video, and today we'll be going over direct variation. So, direct variation. Let me make this a little bigger so you guys can actually read it. Let's see. Okay, so let's pull this up over here. So we have direct variation. And what is direct variation, right? Well, we know that it's a type of linear function or value, like equation. But we don't know really what it is. So, a definition, right? Direct variation equation is a relationship between the x and y coordinates. The x and y coordinates. The x and y coordinates. Can you guys see this? Alright, there we go. The x and y coordinates when one is the multiple of the other. When one is a multiple of the other. So what does this mean, right? So let's get our quick formula out. So it would be y equals kx. That's our formula for the direct variation equation, where k is the slope, and every single direct variation equation, any type of direct variation equation that you encounter will always, no matter what, will always have a y-intercept of 0, meaning that it passes through the origin, where the line passes through the origin. So, for example, we could have y equals 1/3 of x, y equals 4 of x, whatever, but we cannot have a y-intercept other than 0. So, yeah, those are just a few examples. So, now that we really understand what direct variation is, let's go through a few more example and application questions to really see if we understand it. So, just get rid of all of this stuff. So, our first question, right? Y varies directly with x. If y equals -4 when x is equal to 2, find y when x is equal to 6. Right? Find y when x is equal to 6. So what do we do here, right? Well, first of all, we have to see what type of equation we're solving for, right? And immediately we see the first sentence, y varies directly with x. Immediately you should know, okay, that's definitely a direct variation equation. So we know that this is y equals kx. So now we're trying to find the slope, right? Because we have several different coordinate values. We need to find the slope in order to really interpret the question. So we know that y is -4. So -4 equals k times 2, so 2k. From here, divide by 2 on both sides, CL of k is equal to -2. So now that we found our slope, let's quickly make our full equation. So we have y equals -2x. So from here, let's plug in our value for x because we're trying to solve for y. So we know this is the same thing as -6. So -6 times -2 is 12. So our answer would be y equals 12. So just a quick summary, y varies directly with x. Remember to make it into a direct variation equation. If y equals -4 when x is 2, so we know a point is 2, -4. Find y when x is 6, so 6, y. And we're just solving for y using our direct variation equation. Let's do one more of these. These are kind of fun. Alright, let's get rid of this. Oops. So we have y varies directly with x. If y equals -4 and x is equal to -18, find x when y is equal to 12. So from here, right, what do you automatically see? Y varies directly with x. So immediately we know, again, y equals kx. From here we do the same. This is exactly like the question before, except for the fact different numbers, and we're trying to solve for x instead of y. So let's do the same steps. So we know y equals -4 equals k times -18. So k is equal to 2/9. 2/9. So from here, let's draw an arrow. So we have y equals 2/9 x. From here, we know y is equal to 12. So let's input that into y. So 12 equals 2/9 x, right? So equals 2/9 x. So from here, let's just solve for x. So you guys can pull out a calculator if you need to. And this should give you 54. So x is equal to 54. If you multiply 54 into the equation, you should get the answer. So 54 should be your answer. And that's just another quick question about direct derivation applications. Let's do one more, a little bit more harder question. A little bit harder question. So let's get rid of this stuff right over here. So the total cost, right? The total cost of filling gas in a car varies directly with the number of gallons you purchase. If 7 gallons of gas, so if 7 gallons of gas if 7 gallons, well, it would be nice if you could actually see what I'm writing, right? Oops, sorry about that, guys. So if 7 gallons of gas costs $157, how many gallons can you purchase for $15? And this is not supposed to say $157 because that would be absurd. No one would buy that much for alright, it would be $15.7. And then let me just quickly analyze this question. So there you go. This is our question, right? This is basically just like formatted a little differently with a real life example. So let's get we know it's why it varies directly because it's given to the problem, y equals kx. If 7 gallons of gas costs $15.70, then first of all, let's make gallons x and the dollars y. So if y is dollars, right? So 15.7 is equal to 7k. So from here, k is equal to 15. So k is equal to 15.7 divided by 7. And that should give you 2.243. So let's just round it to the first decimal, or tenths place. So it would be 2.2. That's just a rough approximation. You guys can get much more intuitive if you need to. So we know that k is equal to 2.2. So from here, we go arrow. So y is equal to 2.2x. So now we know we need to find x because that's gallons amount because we're trying to find how many gallons can you purchase with $15. So make x 15. And so 15 times 2.2 should give you like 33 around, pretty sure. If you did like the full calculation, I think it's like 33.6 gallons. And that should be your final answer, guys. So now that we've finished going through like questions and application questions, let's go through the graphs of each of these, right? Let's go through the graphs of what these direct variation equations would look like, right? Because when you look at these types of graphs, you really want to see like what they're asking, right? So let's go through a first type of graph. Let's go to Desmos. So we have y is equal to 1/3 x. Oops, 1/3 x. So like that. So as you can see, it's a direct variation equation because it passes through the origin, and it goes up by 1 and goes to the right by 3. So that's the slope, or y equals k of x. So let's go. So that's positively increasing, right? But it's increasing at a pretty slow rate compared to an equation like, let's say we had y. Let's say we had y is equal to 2x, right? You can see it's increasing at a much faster rate. The blue one, y equals 2x. So that just shows that the higher your slope is, or the greater it is, the faster it will increase by slope. So say you wanted to do like, I don't know, 2000x. It looks as if it's a straight line. That's very impressive actually. But say we zoomed out a bit, right? Say we wanted to zoom out like a lot. So like say we wanted to zoom out. Still very, very hard to see, right? But if you zoomed out all the way, you could almost literally see that it's barely, just barely not straight. So that's very, very interesting. It just shows that the greater your slope is, the more closely, I guess you could say, it is to being looking like a line per se. So anyways, let's go through another type of example, right? Let's say we had the graph. Let's say we had the graph y equals negative 10x. Y equals negative 10x. Let's get rid of these two. Now you can see that it's decreasing. And just like when you're increasing, the lower and lower decreases, the closer and closer it is going to be to a line. So let's just say we did 100x, negative 100x. It looks very close to a straight line. Say we did negative 1/2x, negative 1/2x. Now it doesn't look too great. It's not decreasing too quickly. It's decreasing at a moderate rate. So these are just like the quick few applications and tricks that you can use for the slope to really analyze and like see what type of graph it'll create. So yeah, guys, that's pretty much it with direct variation graphs and direct variation in total. We just covered what it is. And so for our last lesson, we're going to be going over slope-intercept form. So this is direct variation form. We're going to be going slope-intercept form, a little bit more intuitive, a little bit more easier to understand now that we understood direct variation. And yeah, I think that would be the last of Unit 5. So thank you for listening to Lesson 2, and I'll see you guys in the next video.